require the scanner for it. So I'm creating a scanner. And I'm going to read or use this scanner to read the input from the console. So that's why I'm supplying the system.in. Then I will print a message to him saying enter number of students. Int number of students equal to sc.next int. So I'll make some, let me explain you some minute points here. And also I would do a little bit change in this next int statement and I'll explain you why I'm doing it. Point number one, if you observe the case that I'm using, when I'm giving a name for a class name, I'm starting it with a capital letter. And if I have a second word in the name, let's say it is a parallel array, so I want to give it as I just given para arrays, but this para is a separate word and arrays is a separate word. So when there is a new word, I've started it with a capital letter again. We call this as a camel case. So a word will start, of course, the name itself will start with a capital letter and every word in a name will be started with a capital letter. If you're not understanding what is every word, so usually in some of the languages, you would follow a notation like this, para underscore a. So they have underscore differentiates or separates two words. But here in Java, you don't use underscores. In very rare cases, you would use underscores. For constant, we will do it. And I'll let you know when we are learning about those things. But for now, for class names, or for any other type names. What is a type name? You'll understand it later. But for now, for the class names, we use camel case. And this is a method, a function. Main is a function or a method. We'll have many such functions. We'll be writing many functions. You'll understand how to write a method when you require a method. Those things you'll understand later. But this is a method, a function. Typically, a function is a named block. I think this I had explained you the first session. So you can have a block without any name. The class level, directly you can write some set of statements like this. But if you give it to a name, you will call it as a named block, or to be precise, you call it as function. In some of the languages, they use a precise or very clear naming standards like named procedures, stored procedures, something like that they use it. So just to indicate that it is simple, it's simply a block with certain name given to it. So that if you want to recurrently use it, recurrently call it, you will be able to use that name to call it. So you will understand those things later. But if there is a function, the function name should always start with a lowercase. What is the name that I have given to it? This is a title case. If I given camel case, that's wrong. This is called title case. Method names will be given in something called camel cases. What is that camel case? In this case, my method has only one word in it, main. So it is all small letters. But in case if I have a second word in the name, that will start with a capital letter. Let us say main method or something like that. If you have a second word, it should start with a capital letter. The second word should start with a capital letter. So we call this as a camel case. Okay. Your variables will also follow a camel case. You see here, I'm giving a name called number of students. So this NO, which represents the number, started with the variable name. In totality, it started with a lowercase. Of is the second word, it started with a capital O, and student is a third word that's also started with a capital S. So this is the cases that you usually follow throughout the Java program. You can see the standard method here called next int. Next, N started with a lowercase. This is a second word in it. It started with a capital I. That is what they followed in the, in the predefined code, pre-existed code. So we would also be following the same cases when we are writing ourselves. So this is about some nuances. What is the change that I'm talking about? Henceforth, when you're reading the integer, or so far when we're reading the integer, we used a method called nextInt, but henceforth we would not be reading it called nextInt. We use something called nextLine. Okay. This nextLine is a method designated to read a string from the console, not an integer from the console. So this next, you can see the return type of this next line. If you put your cursor there, it would be showing you return type. Where is it? So the next line's return type is string, but I'm trying to store that string into int. It is not possible. That is why it is showing an error. So what we can do is we can use some additional methods to convert the string into int. There is a method called integer.parseInt. What is this integer.parseInt? All these things you'll understand slowly. We don't require a dedicated session for it. As we are using it in our programs, you will learn slowly. Integer.parseInt. This is how you read it. Why do you do it? Why not the next int? That was simple, but why don't we use it? That's because it has some, for that to understand, you need to know about IOs. So when we are discussing about IOs, I'll show you, I'll explain you in detail, but for now, just to briefly explain you what is actually the issue with this. Let me show you. I'm now precisely discussing a point of why we are going for the integer.parseInt. Why not the next int? To show you, let us see, I'm reading a value now. A number. Let's see the next int. Number 2. Let's see the next int. Number 1. 1. Number 2 is var2. Let me execute this code. Enter a number 10. Enter a number 2, 20. Number 1 is 10, number 2 is 20. It's reading correct. There is no issue. But assume I'm reading a number and then a string. String. To read the string, you'll have to use next line. Okay, I ran it. It is asking enter a number. I've entered a number, let's say 15 or 12 I'm entering. Then I'm going to press the enter. Press enter. You see, it has printed a message called enter a name, but it didn't wait for my input. It has proceeded forward. Proceeded forward and printed. It has read something from the console. We don't know what it has read. It has read something from a console. I've told you while I was talking about the scanner, I've told you if the data is there in the console, it reads the data. Otherwise, it will wait for the user to enter the data. In this case, it has not waited for me. That means that the data is already there in the console. It has read the data. It has gone ahead, but I'm not able to see what is it. That's because the data which is there in the console is white space or the enter symbol that what I typed in. Every key in your keyboard will have its own ASCII number in it. Even the enter key, though when you press enter, nothing actually happens on the screen. It writes a character called a new line character, /n character. Some of you might know, some of you might not know. Let me show you if you haven't seen that before. Okay, if you see here, wherever it is, if you see here, at the end of each line, you're not seeing anything, but there is show all characters. If you click on it, you'd see there are some special characters which are there at the end. Here also, the moment if I type in the enter character, you'd see it is adding something called CR. CR stands for carries written. LF stands for line feed, which is /n. So enter will actually create a character. So when you are reading the integer using next int, after pressing 12, to let my cursor go ahead, I would usually press enter. That enter is not being read by the next int because the next int will only read the integer content which is available, that is 12. So it reads the 12 and it leaves the pressed enter in the console as it is. So because of the nature that what I have explained you earlier also, this next line method first goes look at the console if the data is already there. If it is not there, it will wait. Otherwise, it will take whatever is there and it will go ahead. Now, this next int method has only taken 1, 2. Those 2 digits alone it has taken as a number and entered in. It left the enter character in the console. This next line, this is actually a character reading method. So the next line is also a valid character for it. So it reads it and then it will go ahead. So it doesn't wait for the user. It already reads that invisible enter character which is there in the console. It will go ahead. So that is a kind of a flaw, or not a flaw, that is how it behaves. So that is why what we usually do is this issue will not come when you're reading everything as a character using next line method, because next line method reads including the enter character what you have typed in, and then it prints that, or to be precise, it terminates the moment it has seen the enter character. It reads the enter character and stop reading from the console. Okay, so that is why what we do, just to avoid it, here also, instead of using next int, we use next line. But next line is a string reading method. So it returns the string, but you cannot store it into integer. So there are helper methods in Java which can convert a string into a number. If you're not able to distinguish between what is string and what is, how can a string become an integer? If you have such doubts, let me explain you. The moment of it, say, if you see 10 here, you will not be able to see whether this 10 is an integer. For us, because we know as a humans, we have the intelligence. The moment I look in 1, 0, I can conceive it as 10. 10 is actually an integer number. So I would say it is an integer number. That is our inferring. Might not be true always. This 10 can be a valid string also, because 1 is a character, 0 is a character. Though they are digits, they're also characters. 1 is a character, 0 is a character. So this can be a string which is made out of 2 characters called 1 and 0. If you're still not able to understand what I'm saying is, this 10 is valid number and valid string also. We don't know what is the intention of writing string, whether they have written it as a string or it is there, or whether they have written it as an integer. That distinction is not simple to make out. Your computer can perceive it as a number, or you can also perceive it as a string. What is the difference? If you, let us say, a computer have perceived it as an integer, then if you used it in an arithmetic calculation, let's say you have written 10 plus 10. You would expect the outcome to 20 because 10 plus 10 is 20. This happens only if your computer have perceived these things as integers. If your computer have perceived these things as strings, this 10 plus 10 will become 1010. 1010. Or 10 plus 2, if you're writing, if computer have read this 10 and 2 as a strings, it will make it as 102, because when you add two strings, it will actually concatenate those things. So it will become 102. But if the 10 and 2 are perceived as integers, it will perform an arithmetic calculation on it and make it a 12. So that's the difference of reading 10 as a string or reading 10 as an integer. This next line method is designed to read that 10 as a string. So if you treat it something like this, maybe I can show you string var1. You don't have to parse it. Just simply use next line. And here, just for the sake, I'm using a pointer. Sorry, I'm using a simple arithmetic additional symbol. I'm reading next line, and reading both these values as strings. Now let me execute the code and show you what would happen. I'm entering 10 and then 2. Press enter. You'd see 102 coming here because it has read those two things as strings and concatenated, become 1 or 2. But I want to read these things as integers so that it can do a proper addition rather than concatenation. So if I have to do it, I'll have to convert these things properly. Read int, I'll have to convert it as integer dot parse int. But to parse a string, it has to be a valid number. You cannot enter a, b, and you cannot ask it to parse it into an integer. It will say parsing parser exception. It has to be a valid number in terms of string, so then it can convert that string into a number. Enter a number. So in this case, if you read it like this, there will not be a problem. It reads both. Number 2, var 2, reading it. Enter number 10. See, it is waiting now because I read it as a next line. So it read the entire, including the new line character. So the buffer is empty now. The console is empty now. So it is waiting here for the next input. Enter 10 and 2. That's why the change. So henceforth, we would always be reading using this way. No next line, no next strings anymore. No anything else. You would always be reading using integer.parse int. Any data type, if you are reading a float, you have float.parse float. If you're reading a double, you have double.parse double. Short.parse short. Long.parse long. Like that, you have methods. You can use those methods to convert the input into a corresponding data types. And that will become a persistent usage for you, because not only when you're reading from, at least when you're reading from a console, you have an option of reading, though it has some flaws in it, you have an option of reading it as an integers, you have option of reading it as the according data types. But when you actually started the web-based coding, you don't have option of reading ints and stuff. Anything which is coming in the internet through HTTP protocol will only come as strings. So you eventually end up using this integer.parsing to convert in case if you are reading it in the web. In case you are reading an integer from a web, you don't have next int and stuff there. You only have the next line, or it will give you as a string directly. You'll have to convert that into an integer, or however, like whatever data type you like to convert, you should be able to pass it. So you can make it a practice from now. So it will be helpful for you, or it will come in naturally for you when you're actually working with the advanced Java. The real-time Java. Okay, so come back to our code. So just to remind you about the problem that we are solving, we have to read number of students If user have entered 5, I'll have to read 5 student names and then 5 student marks. Then I'll have to find out the name of the student who got the maximum number of marks. So here, if you observe earlier, yesterday program, I was only reading one data. Semantically, only one data, like age. I was only reading age. I might have read multiple ages, but I was only reading age. So semantically, it is only age that I was reading. Sometimes I was reading 5 ages, 10 ages. But here, if you observe, I'm reading 2 different data. One is the name, which is actually a string type. The other one is an age, which is a numeric type. Of course, I would be reading multiple of those. Multiple names I would be reading, multiple ages I would be reading. So one thing is clear, because I'm reading multiple semantic data, I require an array. So I require an array for age, I require an array for name. But arrays in its nature cannot hold both together. That means you cannot have the name and you cannot have a age put together, because arrays are of single data types. If you create an integer array, it can only hold integer in it. If it is a string array, it can only hold strings in it. You cannot mix up both. So what we'll be doing is we'll be creating 2 arrays, one array to hold all strings, another array to hold all ages in it. So string, this is how you create a string array. Names equal to new string. I already have read how many names that user is going to enter. How many students are there, that many names will be entered. So I'm creating an array of number of students as. Similarly, I would also create marks array. How many marks, how many students are there, that many marks will be entered, obviously. So number of students. So 2 arrays are created. Now both are empty arrays. What should I do? I have to read the names and I have to read the marks. So to read, I'm entering a loop like this. This out. Enter the data. For data, I would also be mentioning it. We can use the same loop. I'm not going step by step. I'm directly writing it. Less than number of students. I plus plus. Enter the name. Plus 1. Names of I equal to next line. I can read the name directly because name itself is a string. I can read it directly. And then I would enter marks. Okay. So here marks of SC dot next line, but I'll have to pass it. Sure. Okay, so this is how I write it. Let me print out what is there in it. I'll come back and explain you something. So you cannot print array directly like this, like how you are printing a variable, you cannot print. Okay, I'll come back and explain you what is it. I'm printing a names and marks. And let me run my code. I haven't completed. I just I mean, read the input and I'm printing the input as it is, but I don't want to print the as it is. My requirement is to find out the maximum marks student name. So enter name of a number of students. I'm just entering 2 because I wanted to show you something else what's going on. So it is asking the enter student name 1. So I will enter Ram, marks 100. Suresh 90. Okay, if you see here, it is showing something like string some number, I some number. I'm printing arrays basically. This array got 2 names, this marks got 2 names, but it's not printing arrays. Okay, why is it so? That is so because come back to funda that I have explained in the first session or the reference variables, probably day before yesterday's session. I've told you when we create an array, how am I creating an array? I'm writing something like int marks equal to new int. Let me freeze 5 now. In my code, it is dynamic value. Here, assume I'm giving 5. So what's happening there? I'm creating a 5-sized array. That's the right-hand side expression because I wanted the 5 memory blocks. This is a base address. 1001, 2, 3, 4 are maybe a little larger numbers based on the scaling factors also it can be. But for now, take the consecutive numbers. You have consecutive memory locations. But for the left-hand side, I've told you it will create a reference variable. This is marks. We'll have a base address, let's say 2572 or something like that. This base address will be stored in here. If you write data, marks of 0 equal to 25 or something like this, that will store here. That means the memory block for the right-hand side. The left-hand side, what you have is a reference variable. It will not contain the data. It will contain the address of the location where the data is being stored. That's why we call it as a reference variable. There's a discussion what we had while I was talking about the reference variables. Now, in the sysout statement, system.out.println, what am I writing? I'm writing marks. So technically, I'm asking to print the content of the marks. What is the content of the marks? 1000. Just for the simplicity sake, I'm using the numeric decimal values here. But typically, these addresses are hexadecimal numbers. The symbolic references, the little larger in size. That is what is being printed here. What you're seeing here on the console is at the rate. These numbers are hexadecimal numbers. Yesterday, I was explaining you the hexadecimal numbers. I've told you it will have after 9, A, B, C, D, E, F. You see here, E, A, these things are coming. That's because these are hexadecimal numbers. These are the representations of your memory locations. So technically saying this 76FB509A is the address of this block. Not the 1000 for the simplicity sake I've written, but the address of the first element of my array is this one. That is a content of my reference variable. So that is why when I print it, the content of marks is being printed is actually symbolic reference. But if you want the data to be printed, not the content of the marks, but you want the right-hand side value, this data, if you want to print that, if it is a simple variable, it will obviously print. Let's say if the primitive variable like this, int size, this variable. Number of students. This is a simple variable. Primitive variable. Number of students equal to 10 if I write. For this, a variable will be created. 10 gets stored in there, not the memory of 10. It's 10 directly will be stored here. So when you print number of students, the content of that will be printed, which is actually 10. So you would see 10 in the console. That's what you would be expecting. Here, you are expecting the right-hand side value, not the memory location of that. But unexpectedly, when you print the marks, I mean, as it is printing the content of the marks, but you want to go into the memory of, go into the location which is being stored in the marks, and then you'll have to dereference from there into it. So we have to do it. There is one easy way to do it. Arrays dot toString. If you use this method, you can blindly use. You will understand what is this arrays, these things when we are learning about collections. But for now, remember to use arrays.toString names, arrays.toString marks. You run this code. Two students. 15. Krishna. 16. Okay, it's a Rama Krishna. It's coming up. Minus 15 minus what is minus 15? Minus 16. For some reason, there is a hyphen. That's why it is becoming minus 15, minus 16, whatever it is. But you can see the array content as it is coming. That's the right-hand side portion of it. This is how you print your arrays. If you tell you have to print. Okay, fine. So let us go and build the code. How am I going to do it? It's simple. Kindly pay a little attention. I'm going to ask you a question. Okay. Ramu, Raja, Ravi. 98, 99, 87. Can you tell me the name of a student? I mean, the top or name? Maybe you can type in. Somebody typing in. Okay, Raja. Fine. That is because you have inferred something that you assumed this 98 belongs to Ramu, this 99 belongs to Raja, this 87 belongs to Ravi. You're right. But computers does not have any such intelligence. We'll have to let it know. Because computers, especially certain collections, and collection is basically an extension of arrays. Okay, certain collections which you would really be using. Going forward, you would not be using arrays as it is. You would use something called collections in probably 3-4 sessions from today. You'd be using the collection, something like those collections have a tendency to shuffle the data. That means this array will be shuffled, this array will be shuffled. It doesn't mean it won't maintain the order also. It will just randomly shuffle. So if you shuffle, you will not know whose marks are what. But in our case, we will be very consciously storing it. We'll store the 0th element of names array is related to the 0th element of the marks array. The first element of the names array is related to the first element of the marks array. Second element of the names is related to the second element of the marks. So we maintain this relation. If there are multiple arrays in your program, which has the relation maintained through the indexes, you call those things as parallel arrays. I repeat, in case if you have multiple arrays in your program, and the data of those arrays are related by the indexes, you call those things as parallel arrays. So here in our case, the first name Raja is related to the first marks 99. Zeroth name Ramu is related to the zeroth marks 98. If you are consciously maintaining your arrays with that sort of a relation, you call those things as parallel arrays. Okay, and when you're making a primitive programs like this, parallel arrays are inevitable because currently you haven't seen any array or any sort of a storage mechanism or a variable which can hold name and marks together in one single unit. So even if you shuffle, you don't mind about it. That sort of a thing is not there. What am I trying to say is, in case if you have an array where each unit is able to store both the content together. For example, you have something like this where you write Ramu and you write 98. It's a single array where you have Raja and 99 together, maybe as single units. Ravi and 87. You don't have, or you haven't yet seen a mechanism where you can store in one block, you will be able to store Ram on 98, Raja on 99, Ravi and 87. So if you have an ability to store like this, even if they're shuffled, you don't mind, you don't bother much, because even if they're shuffled, the data is stored together. The Ramu's data, everything is stored together. So you don't mind whether the Ramu is at the 0th position, first position, or you shuffled it to second position. However, these circles or these objects, to be precise, shuffle, you don't mind about it. But currently this luxury is not there for us. We are storing the data separate arrays. So we'll have to consciously maintain the order ourselves. So with that, let us go and see our code. We have maintained that order. Though you haven't observed, I don't know, some of you might have observed, if you see, I am using a same loop control variable to read the values into both names and marks. So in one iteration of a loop, I read the name. In the same iteration, I also have read the student marks. Use the same I. So if the I is 0, names of 0 will get the name of the 0th student. That means the first student. And marks of 0 will get the first student marks. So like this, I'm reading the name and marks together, which will make sure that parallelism in the arrays, or that symmetry in arrays. So while reading it, I made sure the arrays are maintaining that index relation. So while finding out the name of the maximum marks student, I use that relation. So what am I going to do now is I'll iterate in the marks array to find out the maximum, what is the maximum mark and in which index it is there. That's what I'm going to calculate. How to do it? I will run a loop. I take an assumed max. I'll assume some number as a max. What is it? I'll assume I'm going by, these are not optimal algorithms. We have predefined algorithms to do it, but still to achieve it quickly, I'm doing it. So I'm assuming the max is the first student marks as the maximum. Then I'm iterating I less than number of students I plus plus. So you can get the array's length in a different way also. If you don't have a dedicated variable, you can use, let's say, marks dot. There is a property called length. This is not a method. I'm not using like this. I'm just directly writing max dot length. Pay attention. This will give you the size of the array. The size of the array is equivalent to the number of students entered. So obviously, either you can use number of students or you can use marks dot length or any array for that matter. Names dot length also you can use to know how many elements are there. Yeah, what I do is assume if the marks of I is greater than assumed max, then gm max equal to marks. Maybe for now I'll just give a name to it as max value, marks. I will also create max index equal to 0. Okay, so here, let me explain you what have I done here. I've created a variable called max marks. I've stored the first marks, which is 98. And then I've created another variable called max index. I've stored 0 in there. Now I'm running a loop from the first index till the last. In the array which I have taken here, there are only 2 left, but there can be multiple also. What I would be doing is I would be iterating from the first index till I reach the end of the array. That is what this loop is doing. It is iterating. Simply, it is iterating from the first index or index number 1 till the end of it. In each iteration, what am I doing is I am taking the value or the marks available and comparing that with already available maximum marks. Already available maximum marks is 98. I'm comparing whether 98 is greater than 99. That's what I did here. You would see max of marks, which is actually 99, is greater than max marks. Max marks in our case is 98. 99 greater than 98. Condition satisfied. So what am I doing is I am changing the value of max marks with the marks of I. So max marks was 98. I would remove 98 from there, and marks of 1 is actually 99. So I'd be storing 99 here. And then I would change max index to I. I is currently 1. So this 0 will be removed and 1 will be kept in there. Then the loop will take the next iteration, which is actually 2. I read the value from there, which is 87. So I'm comparing 87 greater than max marks. Currently, the max marks is 99. 87 greater than 99, condition failed. So it will not go. No change will happen to the values which are available here in this. And then, in my case, the I value will become 3. Array size is 3. 3 lesser than 3, condition will be failed here. So the loop will be terminated. I'll come out of it. So at the end of this loop, max index will contain the index where the maximum number of marks are there, and max marks will contain the maximum number of marks, which is 99 in my case. So I now know the index, which is actually 1, where I have the maximum number of marks. If I have to get the name of a student, I'll go to the names array and read the name which is available there in the same index. That will give me the name of the student, because I know these 2 arrays are maintaining the relation through the indexes. So if I know an index of a marks, I'll be able to get the corresponding student name by looking at the same index in the names array. So here, I don't want to print the entire marks and names and stuff. I'll just print names of names of max index. This will give me the maximum mark, the student with the maximum marks. I would run this. Number of students. I'll take 4 students. Name of student 1, Rama. Marks, student 198. Sita, 99. Sita, 100. Ramesh, 97. So Sita is the one who got 100, so it's the maximum marks. You see Sita as a name that's coming up. But the maximum marks too. Okay, so this is how we do it. Here we call these things as parallel program. You might know if you observe the third process while we are writing a code, our major worry is about how to read, how to relate these arrays rather than the business logic. This is a problem that we usually have when we are working with parallel arrays. Here, we only have two parallel arrays. Imagine a real business scenario, like a banking or an insurance domain or something like that, where you have 30, 40. You imagine a simple credit card application that you might have filled, some of you might have filled, or a bank account opening, savings account opening form, if you see, it will have at least 100, 200 fields. If you maintain 100, 200 arrays for each kind of a data that you're reading, if you're maintaining an array, so obviously it will be 100 arrays or 200 arrays. And if you have to maintain the parallelism between these 100 arrays, getting the value, maintaining this parallelism, corresponding these data will become a hell of a lot of work rather than thinking about your business. If a requirement is given, your major worry would be like how to find out the relation between the data will become a major worry for you. Okay, that's where precisely we require the data types in whole. So, okay, we require the data types which can hold the complex data, heterogeneous data. What do you mean by that is you require a variable to how can we simplify this process instead of maintaining something like this. Let me show you. What is the expectation is, if we have an option, 1 second, let me connect the power cable. Okay, so what is the expectation is, instead of maintaining, so let us say if student, you're talking about students, instead of thinking student as a string and name, you think about student as a single unit. All the information related to the student you maintain within that particular unit. Something like this. Let's say you have 3 students. You will create one unit. Second one. Then third one, 3 students. Okay, 3 units. Within here, let us say you have 2 different data that you're reading. You're reading name and you're reading marks. Student name, let's say Rama. Number of marks, 97. Krishna, 87. 87. Sita, 99, something like this. Now, if you identify the marks, you don't have to find out where the name will be. Where you got the marks, where you have the name. You get it from there directly. If this sort of an ability is there for us, it can be it can be an array or however you want it. But if that facility is there where we can have objects maintained, something like that. It will be easy for us, much easier for us. Technically, what am I trying to say is, in a business, when you're coding for a business, you will have multiple players in a business. Let us say you are working on a banking application. You have a player, nouns in a business. Let's say bank account is a name, customer is a name, bank employee, like accountant is a name, manager is a noun. All these are the players of a business. They do some operations too. Let us say if a customer there, customer deposit and he withdraws. That is a functionality that customer does. But who is the player? Customer is doing it. Similarly, an accountant, he might ledger the balances, he might verify your balance, and might give you a cash. These are all the operations that you do, but he's the player who is doing that. So what we usually have in a business, when you are automating a business or when you are virtualizing a business in a project, what we do is we identify all the business players available, and you if you I mean you start to treat those business players as the business as single units in your code too. You stop seeing the individual properties of a player. You stop seeing them as a bunch of arrays. You start to see them as virtual objects. You imagine the game that if you play a computer game, how you see a virtual human being there. Of course, physically you can see virtually you can see a complete human being, but when you are coding in Java, you would imagine your mind, but you would see all the properties of a physical human being to one particular entity for one unit in your code. You operate a student as a student instead of name or age or something like that. So that ability comes to you through object-oriented programming. What you're seeing on the screen there are objects. You think your program in terms of objects in your code. So that's why you call it as an object-oriented programming. Java is an object-oriented programming, and Java got an instant hit because it has given you an ability to see these business objects as it is in your code in the virtual world also. So that you don't have to struggle between the arrays and parallel arrays. You don't have to see them in the dissected nature. You can see your business as it is in your code. So that has brought in, though the change is simple, it has brought in so much of ease in the programming, how you can connect your program to your business. So that is why an object-oriented programming become an instant hit. And as early players who have given the complete object-oriented programming support in its fullest length, Java also become an instant hit because of this variability of seeing a real world object as a ability to construct a virtual object to represent a real world object. Okay. Any doubts so far? That's a context of why we require an object-oriented programming. How do we create it? Just into I'm not going to the details of explaining what I'm going to do it, but I will do that stuff. What we have there, I'll do it, but not in Java. I'll do it in JavaScript and show you why you will understand. Okay, what we do, we were maintaining like this names equal to. In JavaScript, we write like this. Names, if you can write like that directly. I'm not going to read, by the way. No arrays. Then this one marks equal to 19. But if you start creating an object, you don't do it. How to do it? Like this. Where student is equal to create an array and put those things together. Name theta marks 99. Like this. Here the name theta. Marks 98. Name marks 100. Like this. It's an array, but not an individual array like this. I created a single array and each unit inside the array contain both name and marks. This is an object. This is another object. This is another object. While coding, you can do something like this. I less than you can insert I plus plus marks equal to students of 0. Now, if I write student of 0, I get the entire unit. And I only want the marks. So I can put dot. Notations are usually same in between JavaScript and Java, but Java I'll introduce you completely tomorrow. Why I'm not going into Java now, you will understand that tomorrow too. But I hope you will be able to understand what I'm doing here. So similarly, instead of starting with from 0, because the 0 is my assumption as the maximum one. So I start comparing with the first one. Say if the student, the first student's marks is greater than max marks that what I have. I do something like this. Topper. I assume the topper as student 0 as the topper. Topper dot marks. You see? Now I'm iterating from the first student. Is first student in the sense first index to student. It's actually second student. Second student marks are greater than the topper marks. Then obviously the topper is the second student. Even in this simple program, you can see the terminology change. I am not now looking at the integer marks or something like that. I'm able to see the topper as a topper, second student, the topper student, something like that I'm comparing. So first, second student marks greater than topper marks, then the topper is the second student. And then assume that currently the topper is the second student. In the next iteration, I compare obviously the third student marks. I value will become 2, who is the third student. Third student marks greater than then topper. Still the topper is Geeta. So Geeta's marks then third student will become the topper. At the end of the loop, you write console.log. You print topper, you'll have name and marks together there. If you want to print only the name, you can write topper.name, something like that. Let me reveal it. Explode. Let me open directly in this project. To run it, we require a see Lata marks and the topper. Now you don't have to worry about what is this stuff, but you can look at the program and how the thought process is changed from and using maintaining an arrays like this to maintaining an objects like this, array of objects like this. I'm now able to see a student as a student. So now these objects become a key players. So that's why we call these things as an object-oriented programming. You program around the objects instead of arrays and single variables or individual variables. There's a pre-note of why we require object-oriented programming and how Java achieves this object-oriented programming is all what you're going to learn in object-oriented programming for the next 2 sessions. Okay, that's about it. I hope the exercises are shared with you. Just if it's not shared, I would ask the coordinator again. You get your exercises. Please try to look at those exercises and see how many of those can be solved by you. And in case if you have any doubts, please let me know. I'll help you solve those stuff. Or if you have any other doubts from today's session, you can ask me. Or you can type into. Type anything. Okay. Thank you. Thanks for your time. Bye-bye.